Thank you, Anne. Thank you very much. It's a pleasure to be here and to share with you our experiences with process mining. I would like to catch up what Jan told us before, no limits. So we are going now to talk about manufacturing environment, industrial environment. What do we do with Disco? And we work since almost 1 year with process mining. And for us, it's really a change management that's going on. And I would like to start to give you first the context where we use process mining in order that you get a little bit a big picture. And start with an information about our company, our group, and then explain you a little bit the challenges that we face. And then tell you something about our products, the processes, and then some facts and figures. Zimmer Biomet. Zimmer Biomet was founded in 1928 in Warsaw, Indiana, in the US. It's a US company. And we produce implants. We are a global leader, a global player in the medical device industry. We bought last year in June a competitor called Biomet. And we doubled our headcount from one day after the other. We are still in a consolidation phase at the moment. We run manufacturing sites all over the world. We have various distribution centers and low-risk distributor center that have the direct contact to the hospitals. And especially in Europe, we have 8 manufacturing sites. One of them is Winterthur. Winterthur is located in Switzerland, next to Zurich. And Winterthur is at the same time headquarters for EMEA and one of the 4 strategic sites of Zimmer Biomet. We are around 1,000 people located there, and around 640 are productive in our production. We face a lot of challenges at the moment. We have external ones like the change in the hospital way of thinking. Before, we have the surgeons that decided what kind of implants of which company they would like to use. Now, since a few years, they started to pool their requirements in order to get better conditions. And we have also, an implant stem, for example, is not rocket science. So the comparability of the products from one company to the other is very, very easy. So we face at the moment a very aggressive market from that standpoint. And then we face another problem, that's the internal one. So when you merge, you start consolidation phases. So we have now the effect that the products are transferred from one company or from one manufacturing site to the other. And we have also sites in China, very modern sites, very good ones with overcapacity. So it's really important for us in Switzerland to become really agile and good in our processes. So this was the reason why I started to try to find other ways, other methods to be able to analyze our processes, the material flows, and so on. Against this background, we had our new Senior Vice President for Operations, Robin Barney, that made the following statement. This is a marathon and not a sprint. Pace yourself and your organization, set stretch goals, yes, but realistic ones. And the mission of the department where I'm working for at Zimmer Biomet, our department is called Operational Intelligence. I'm one of the senior business analysts. is to cooperate together with the manufacturing department and be like internal councils in order that they develop faster. In our group, we are 7 team members. We are specialists with a specific know-how. So my know-how is supply chain and operation management. Then I have a colleague. He is really focused on risk management. Another one on validation processes. Another one again on factory planning. So we are able, when we start to optimize or re-engineer processes, to put different perspectives on the processes that we analyze, and really to consider as lot things as possible. Well, now I would like to present you a little bit our the manufacturing department. So we have our building is spread over. As our site, our plant is spread over 2 buildings and is distinguished by a very high production intensity. So we start from raw material here, from the forging of the part. So we cut the bars, forge the parts. This is done by a non-forging, which is a business unit. They deliver also to third markets or to sister company, but mainly to the internal departments. And then we have 3 mechanical departments that do the processing of the parts. We split the responsibilities with the products. So we have one that does stamps and knees, another one that does trauma parts like plates, screws, spine stuff, and the third one, the whole rest. You see again the range of products and where they go into. So we cover quite a lot. And yes, so this is also a very important slide in order to give you a bit an idea about the big, wide range of processes that we have in-house in order to process our parts. We have some more, but this is the standard manufacturing flow coming, as I told you before, from the forging, going over blasting operation, milling operation, drilling, polish operation. Very, very important for us, quality. So we have lots of measurement center, in-process measurements. We have a laser marking, pre-cleaning, and then we have also some processes that we don't have in-house, maybe due to strategic decisions or due to the complex or very expensive technology that we make outside, like the coating, where we have partners that do this for us. And then a final cleaning, pack and seal, shrink wrapping, then again go outside to our sterilization partner, where we sterilize our products with gamma rays or with gas before we send them to our distribution center. Well, this gives you a little bit an idea about the processes and the products, then some information about facts and figures. We produced in 2015 1 million manufacturing hours, over 440 workstations. Then we processed around 33,000 production orders, and this is related to around 620 work steps. And we have at the moment around 6,500 active articles. And this is the result of it. Yes, so it's quite an intransparent network. So that's why we really have to find a way how to get quickly on the right path and become agile. So that's now really important in order to face the requirements of our vice president and to hit the targets given by Robin Barney. And our team is responsible to set the speed and in order to tackle the marathon here. So very important to find the right direction. And yes, that's why we developed a strategic platform together with operation. Speed stands not only for velocity, but it's also an acronym. So every single, you know this problem, Anne? Oh, voilà. We have every single letter has a special meaning. So speed, the S, stands for standard cost reduction. This is a very challenging target because we are in competition with low-cost countries. We have the paperless production, so we have a lot of paper in our production. One production order has approximately 30 pages, and then we have our control papers behind with another 60 papers, so 90 sheets. And then if we multiply it by the 33,000 production orders that we have, so it's quite a big amount of paper and of work because they need to be filled out by hand and so on. So here we have projects like MES. It's a manufacturing execution system that we would like to implement. And very important before you implement this kind of softwares is to standardize the processes, to identify failures in the processes in order to be able to implement it faster and better. So that's why I'm started to use it, Disco, in order to define a little bit, to find out a little bit the weak processes. Then we have the engineering and innovation. There we mean not the product innovation and engineering, more technologies in the manufacturing side and methods like material flows methods, like new steering or scheduling methods, etc. And the E, that's one of the most important segment at the moment. That's where really I'm strongly working on it with process mining and my colleagues from the manufacturing department. That's this point here, throughput time reduction. So the idea behind is, I mean, we have to focus on the strengths that we have in Switzerland. To go over costs and be in competition with China, for example, it's quite hard for us. So one point could be the agility. So we are in Europe, so we can be very fast at our customers instead of compared to China that they have to ship it over. So this is one point where we really focus at the moment, where I'm showing you some example how I'm using Disco and how we did it before we have Disco. And the last point, the delivery performance, internal delivery performance from one process to the other, and also the external delivery performance of the supplier that are involved in our value chain. Well, excuse me. So this is Boney, a friend of mine, always very curious. Where do we start when we make an analysis of the material flows? Normally, we take out our data from our ERP system. We have SAP. We have timestamps coming from the manufacturing department when they finish an operation. So I take them out for the scope, defined scope. It can be the whole production or maybe something of just a family or specific SKUs. And then I start to identify the waste. One analysis that I made a few months ago was the one of the external processing of the parts. An extended workbench means, as I told you before, send the pieces. So we are still in a production flow, in a production order, then we send out the parts, process them, send them back, and then they go again into the flow. So very important for us and very important for the consequent processes that they know when they receive the material in order to plan their capacity, plan, do the scheduling, etc. And what I have seen was this 29.8 days. Doesn't mean a lot for you, but if I show you this here, we have the throughput time for production orders going over this extended workbench of 43 days, and this 29.8 day correspond to 68% of the throughput time. So a lot of waste. And at the same time, we analyzed, so I made also the comparison about the master data. So I checked in the system, in our ERP system, the throughput time for this process step, and I've seen 10, so 10 to 29.8 days, a huge difference in what we have in the system and what's the base for our scheduling and what we have in reality. Then here I show you another example of an extended workbench. This is the sterilization process, again, 60.1, 3.9. And if we have a look, the first line here, this is the gas sterilization. We have more or less 1/3 of the throughput time coming from this step. And again, not really a difference in between master data and reality. That's okay. But here, again, 0 against 3.9. So having this kind of data in the system means to start systematically too late with our production orders. So we run into backlogs. The same thing happens on other extended workbench where we do milling and some other processes. That's here on this chart we see the summary. We have on this axis the percentage of the throughput time of the single process step in comparison to the whole product throughput time. If we have a look to Sterigenics, we find again the 16.8 days, what corresponds to 38% of the whole throughput time. And here, the aim or the target should be to move all the supplier here on the right to the left. What we did here was to organize workshops together with the strategic purchasing department, the scheduler that are responsible for the supplier. And we did a brainstorming. So main activities here at the moment is to change the tenor against the supplier, to try to have a partnership with them, to improve the communication, to send them forecasts in order that they know what they have to expect so that they can do their planning and install KPIs to really measure them in order to be sure that they keep this delivery performance. And here on this chart we see the effect of the master data. So blue here is what I measured with Disco, and this is what we have in the system. So this was also one action that we did right after the workshop, was to adapt the data in the system in order to be in line with real data. And it's now, so we will do this in a turnus of 3 months, recheck it with Disco, and have a look where we are in the system in order to improve the scheduling. Okay, so now how we did it before we started to work with process mining. So we did it like a lot of other companies. We used mainly tools coming from the lean philosophy and the automotive industry. And I would like to show you two examples. One is the spaghetti diagram, neither something to eat nor the disco visualization map. That's a method to visualize the flows of the material. We see it here. And to identify the waste. And I have a friend of mine called Alex. He works for the Department of the Stamps and got the job from his boss to optimize the material flows. And the idea was to shift the machines that we have spread a bit all over the plant in order to reach our target of the 20 days throughput time. So he started to draw the lines, and he didn't consider one thing. It was this, the variety. So that's only one stamp family, the Yellow Classic, and we have about 52 different articles that can go over different paths using different machines. So after 1/3 he stopped to draw because he didn't have any more space on this A0 sheet, and he was a little bit desperate. So I offered him to do a workshop with me and have a look to a new tool that I discovered last year. And but before that, just some bullets here concerning weaknesses. And really, I think that the spaghetti diagram is a good tool, but it's not really valuable for us because we don't have really due to the high product mix that we have, the high volumes, we don't really have the framework to use it. So we had this problematic reproduction of the paths because of this problem of the big amount of the articles, the extremely extensive job to draw the line, and inappropriate database for analysis with software. That's also a very important point for us. I mean, if you invest as much time, you would like to be able to use them maybe for other analysis, and if you do it on paper, doesn't work. The second method that I would like to show you is the value stream mapping. Also coming from the lean tool set, and really useful in the automotive industry with narrow product families and few customers. Going to the production and really check workstation after workstation, what's the stock of material there, what's the processing time. It's very effective to identify waste, and but not really to optimize throughput time in our environment. Why? This station here, this workstation, due to the fact that we have a job shop organization and not a production line, are crossed by other families. So this snapshot here considers just one family. So as soon as you cross with other families, you have other situations. And I just said it before, it's a snapshot first of all. So maybe the things can change as soon as something happens in the production. You don't know it. And it's also an extremely extensive job to draw the lines and do the pictures. And this problem here is the one that I told you before about this crossing of the families. Well, how do we manage it today with process mining? I told you before, I invited Alex to come into this workshop with his list of articles. Then I extracted the data of 1 year. It took me 15 minutes. Then I put it into the system. And his first answer when he had seen this was, wow, what's that? Okay. I didn't explain him a lot. I just animated the disco visualization, and he was really able easily to identify by himself very quickly where we have the problem. So this was his statement, look at this. No, he was really, really happy. And now we come back to the discussion of the change management. So I installed Disco on my laptop, and in all meetings where I am, and I see maybe a little potential for Disco, I open it, and I start to visualize and animate. And it's really very successful. So that's how I'm spreading a little bit the virus into the company. Well, so very fast processing of big data volumes, that's one of the big advantages. Then the very good visualization tool, the high level analysis that you can perform and then go into the details, so very useful when you organize workshops, also with people coming from the shop floor. And the possibility to export the data. So I gave Alex a nice Excel sheet, established also in a few minutes, and so he was happy and able to go on with his analysis. Well, very important using process mining from my standpoint is to be aware about what you want to do with it. So to have an idea about the amount of the data to take out from the system, because you can have technical problems. So the first exports with 620,000 lines that I had led to a crash. So I was not able to take them out of the system on one time. I had to do lots of turnarounds. So I had another friend of mine, another fan of Disco now, Mr. Solterman, that did this for me. That's an Access database and interface coupled to some tables in SAP, a lot of technical stuff where I'm not really confident with. And now it works very well. So then think about the period that you want to analyze. So normally I use 1 year, but sometimes it's good to take 2 or 3 in order to really have good mean data and a good quality of data. Sometimes, on the other hand, it's maybe not necessary to go so far because you do only rough analysis. So it's a little bit, there are little bit things that you have to consider. Very, very important is this point here, the plausibility check. Before I go with my analysis out into the workshops, it's very important to do these plausibility checks with someone from the production that knows really the processes, because otherwise you could have a loss of credibility, and people, they feel, the first impact is always they feel attacked, and as soon as they see that you have a weak point, they use it against you. So check check the amount of the cases, if the variants are plausible throughput time, these points. Well, lessons learned. It's really, I said it before, important to know in what kind of environment you use specific methods. So we think, so at our company, we had a lot of people think, oh, the automotive industry, they are the ones. But you really need to have a close look how your production is organized and then choose the right method. I think that for throughput analysis in our environment, the value stream mapping and spaghetti diagram is not good enough. It was the reason because I was looking for something else. Then it's fundamental before starting with an analysis method to know what's the outcome, what kind of data would you like to have at the end, data that you can maybe use for further analysis, also very important. And yes, this is again the point with electronic data in order to do other analysis. Well, what does process mining mean for us? Process mining is for us the first step into analysis of big data. So we started 2 years ago to gather data of our machines, put them on OPC servers. So we have already a huge amount of data, but the problem that we are not able yet to use them for analysis. And Disco process mining gave us a first idea how we can do it. So it's like a first step into the future for us. But we are really, really at the beginning. Then it's a really new efficient method for the workshops. Also with people that maybe don't have a really big background about methods and stuff. And yes, the sensitization of the people. So a picture is worth 1,000 words. So that's the experience that I made, and really a point that works very well. Yes, I hope that I was able to give you a little bit an impression about how process mining could work in a manufacturing environment. And I made the experience that I didn't met a lot of people coming from this area. I don't know if someone here works in a manufacturing environment, because it would be great if I could share a little bit the experiences. And now you have the opportunity to ask your questions.
Thank you. Let's first give Giancarlo a round of applause. I'll start with the first question. You can raise your hand, and then the microphone will be brought to you if you have another question as well. So, Giancarlo, I was wondering, so you were talking about these existing methods that are being used, and there's a Lean Six Sigma group or Lean Six Sigma experts also in the company, right, who have, let's say, all the whole Lean Six Sigma toolbox at their disposal. So how open did you find them to, towards such a new method, which is not traditionally in their Lean Six Sigma toolbox?
Very motivated to use these new tools. I mean, lots of our manufacturing engineers doing this analysis with me are 30, 35, and they are aware of this problematic of big data, and so they are very open-minded against this, but the problem is to find on the market tools that really help you to analyze these material flows. So that's a great thing, and I'm very happy to have people that sustain me on this. Yeah, they are often pushed by their old-fashioned chefs to do value stream mapping, because it's a quite effective method. But no, I'm okay with it. So.
Okay, thank you. Let's wait for the microphone.
There was a slide in your presentation where you showed there was a discrepancy between the data you had from Disco and SAP. Where from this discrepancy is coming? Does it mean SAP was not so reliable?
I asked the same question. The colleague told me, look, I made an inquiry. The supplier made an offer. He told me that he's going to be able to deliver the part within 10 days, and that's it. So he has to deliver within the 10 days. So we put the data into the system, and that's it. No one went down into the shop floor and started to analyze what he really did. So they were not interested to. So the idea was he has to, and he is not able to deliver within the 10 days. We are going to punish him. But that I didn't realize that this could have an impact also on other areas of the product planification and the scheduling. So I had to explain to him, listen, it's okay, you're right, it's an agreement with the supplier, but that's not the right platform to put pressure on the supplier, because leaving the 10 days, at the end, we will have the problem inside our production. But he checked it now. So.
My question is, what is the current status of your optimization of your process, and how do you use or intend to use process mining in combination with other methods for the optimization?
Okay, yes, so we are in a very early stage of using process mining. At the moment, we run this MES project where we have, where I analyze the material flows, and I coupled it with SIPOC. That's a method coming from the Six Sigma, where I really have a close look to all process steps and try to identify weakness like this. And it helps me, so DISCO helps me to identify already the hotspots. So if I see that I have problems maybe on milling, I know that when I do my SIPOC on milling to go more into the deep, because I know that according to DISCO I have a bottleneck there. So that's how I couple a little bit the DISCO, the process mining, together with this project. And well, then we will see what the future will bring. But at the moment it's a one-man show, so I'm the only one with the license, and we will see when we will discuss about the future if we can spread it. So we have people interested to have this tool on their laptop, and then maybe we will be able to couple it with other methods.
More questions from the audience? Let's wait for the microphone.
Hi.
Hi.
How important do you think that has been to have a visual tool to show the people in the workshop the real process? Do you think that it's determinate?
I can hear you very well, excuse me.
Sorry. How important do you think that has been to have a visual tool to show the people in your workshops the real process? Do you think that it has been determined to engage the people in perform some change?
Yeah. So you mean if how I worked with the how is the readiness to work with the tool in the workshops in the manufacturing department? Okay. Now they are quite open. So I was very surprised about when I was talking to them how far they are with their thinking about material flows and optimization. And but the main problem that they have, they are really focused on maybe their machine or maybe the flow of the products that they are producing. So when I am down in the shop floor, I'm able to show them a little bit the whole network and give them a little bit an idea about what happens if he decides to produce maybe instead of only one production order, 2 or 3, in order to not to have a lot of setup time all the time when he has to change the tooling. What are the consequences? So he produces instead of 90, 200, and the subsequent process, for example, is not able to process the 200 coming, so he creates bottlenecks. So and this is a little bit also how I'm working with the people to give them a little bit this overview about the whole network. And that's very easy doing this with process mining. So they are quite happy and they cooperate really.
Giancarlo, I remember this one story which you once told, that you were talking to someone responsible for a specific process area, right? And they, once upon realizing that the extended workbench can take longer than they expected, they realized that, well, in some situations, maybe it would be better not to give it to the extended workbench, but actually to keep it in-house. So.
That's we have 2 reasons why we use extended workbench. One reason is because we don't have the process in-house. And the other reason is when we don't have any more capacity in-house, for example, on a milling station, so we have parts that do the milling outside. And the idea is if I give it outside, I'll get it back earlier because they can start and do the thing. But what I didn't realize is if you start to do this analysis of the extended workbench that I made now, that at the end of the day, it would have been better to wait that these bottlenecks at the milling would have been solved than to give it outside. And this was not really visible for them. So they thought, okay, we work with the suppliers and we will win anyway if we give it out. But it was not like this. And I see a lot of time these effects. So, and at the end of the day, it costs more than do it by yourself in your own manufacturing.
Yeah. Maybe one last quick question. Okay.
Hi, so yes, I'm conducting my second external process mining project right now, and I would like to know how much of the process mining analysis you are doing are used on acquiring the data, and how much is manually acquired when you have gaps in the systems that you don't have. You said you were going to be paperless. I reckon you still have a lot of manually data. How much of that time is being put into,
Also, much more time than using disk to analyze it. No, the main point is, so I'm quite happy with our ERP system, with the SAP. So the main problem was not the quality of the data, so it was more the amount of the data. But this was probably more an IT infrastructural problem that we have, and the only thing that that I would like to have is we use just to stamp the finishing of the work steps. So it would be great to stamp also the beginning of the work step in order to have also the real processing time on the workstation. And at the moment, if we see the throughput time that I showed you before, it goes always from the last stamp of the finishing of the process till the end of, for example, the extended workbench. So the process time is always included in this throughput time. So this is just one thing that I would like to have, but it's due to organizational reasons that we don't have it. But I guess that when we are going to install MES, this is going to become much easier for us, and I'm convinced that then I can push more process mining because we will have more detailed data in real time coming from MES. Yeah.
Okay, great. Thanks a lot, Giancarlo. Let's give Giancarlo another applause.
Thank you.